So let's start. Good evening, everyone. Uh, I hope you can
Good
hear me.
evening, sir.
Okay.
Yes, sir.
So today we will discuss. Yeah, today is the 11th week of the weekly live problem solving session for the course Energy Resource Economics and Environment. My name is Sandeep Yadav and I'm a Prime Minister's Research Fellow at Department of Energy Science and Engineering, IIT Bombay. I'm a teaching assistant for this course and taking a weekly live sessions, problem solving sessions in the past 11 weeks. So this is the second last week of this course. I will be helping you in the solving the numerical problems in the net energy analysis examples and few of the energy policy studies theories. So before starting, I just wanted to know if anyone of you having facing any doubts on the solving the quizzes and all, so that we can clear it. Okay. So I will start with the previous week's quiz problem solvings. So let's go through the previous weeks. Yeah. So this is the week 10's assignment. So question number one. This is the input data given for the multiple questions. Here, this is the energy flow diagram for electricity generation from the coal power plant to the operator pump. So here we can see a coal is being used from the mine from the coal mining with the efficiency of 90%. And then it is fed into a thermal power plant for the electricity generation, which is having an efficiency of 35%. Now from the thermal power plant, electricity is generated, and in the transmission, the distribution, 20% of energy generated is being lost, and electricity reaches to the farmer, and farmer uses it for the agriculture use to run a motor, which is having efficiency of 85%. And a motor is used to run a pump, which is showing a efficiency of 70%. Now we have finally in the at the end use, we are getting a 5 gigajoule of energy per year. Now we have to answer following questions. The energy input to the electric motor. So here it is asking what is the energy input to the electric motor. So we can typically divide. We know the output, we know the efficiency. We can just divide it by the efficiency and we can get the energy input. So here's the thing, energy output, we know 5 megajoule. Energy efficiency, there are two energy efficiencies associated with this. One is efficiency of the pump and another is efficiency of motor. So we are dividing with both 0.85 and 0.70. Finally, we are getting energy input as 8.4 gigajoule. I hope this is clear. If not, you can ask raise your questions if any. So that was very basic one. Now moving to the question number 2. What is the electricity supplied to farmers annually? Now, this is the energy given in the energy flow rate, that is a 5 gigajoule per year. Now, we need to calculate it. What is the energy electricity reaches to the farmer? So that we can calculate, we know 8.4 gigajoule input is given to the motor, and we know the out of, so you know electricity to the farmer. We know that 8.4 gigajoule input given to the motor. We know the output of the for the farmer that we have just calculated 8.4. Similarly, we can multiply it by 10 raised to power 9 because we know gigajoule is converting gigajoule to joule. It reaches to 10 raised to power 9, and we are doing it for hourly basis. For the kilowatt, we are multiplying with 3600 because of converting it to the hour. It's for the annual basis, and then finally we are getting the answer of 233 kilowatt hour. I hope it is also clear. Not you can ask. In the same relation, question number 3. Question number 3 says the overall efficiency of the pump. So overall efficiency, we need to multiply all these efficiencies into the and we can calculate the overall efficiencies. So overall efficiency will be 0.9, 0.35, 0.8 into 0.85 into 0.70. That it comes out to be around 15%. So you can it's a numerical input question, so you have to do it very precisely. So the answer range will be 14 point from the range of 14.5 to 15.50. You can also input the value as a 50.15. So that's all for the starting three questions. Now moving to the question number 4, it says for the given energy flow diagram, if the calorific value of the coal is 4800 kilocalorie per kg. Now the amount of coal needed annually is. So we know the calorific value, we know the input primary energy. So input primary energy would be output useful energy that we that is given in the question, that is 5 gigajoule. Apart from that, we know the overall efficiency also, that is for 15% around. Then we can calculate the input primary energy. The input primary energy will be 5 divided by 0.1499. That it comes out to be 13.33.36 gigajoule. Now 1 kg of coal having a calorific value of 4800. Now converting it to the kilojoule, so can multiply by 4.184. Hence 13.36 gigajoule will be equal to gigajoule conversion will be 10 per 9, and coal conversion will be 4800 into 4.184 into 10 per 3, and it comes out to be 1662 kgs of coal. So it's a 2 marks question. So you need to solve it very precisely, and you will get the full marks if you just solve this question. This type of question may also come in the numerical input. You will not given the options. You have to put the input answers in that format. Is it clear? So these all the starting four questions are interrelated. If you are getting any of the questions wrong in the initially, then your answers for the all the questions will be wrong. So solve the questions very efficiently and do it because the online calculator will be provided in the exams. So just do it step by step, and then you will follow the methodologies. So moving to the question number 5, it says if the type of coal used has 40% of the carbon content, then the annual CO2 emissions will be. So we know CO2 emissions is the amount of coal used to the carbon content. So here amount of coal used will be that's a log rate. The amount of coal used will be 16.62 kgs. So that will be 16.62 and 1662 into 0.4 into 44 divided by 12. That comes out to be 2.436, and the nearest answer that you will get is 2.6 tons. So that will be the final answer. Now moving to the question number 6. While performing life cycle analysis, dash is the quantified performance of a product system which is used as a reference. So as we have studied in the theory parts, functional unit is the quantitative performance of a product system which is used as a reference unit. If you need more explanation, you can just visit the lecture number 21A time snap 1045. I hope this is clear to all of you. Moving to the question number 7. It says Life cycle analysis looks into the chain of a product's life cycle from a grave to cradle. Is it true or false? So it's basically a false statement. So the statement should be LCA looks into a product life cycle from the cradle to grave, not the from grave to cradle. Question number 8, it says new policies introduced in a campus to replace existing intra-campus transit buses with electric shuttle buses. An initiative shows that the net energy ratio is 0.8. Is it replacement viable or not for the basis of NER? So as we know, NER is below 1 will not be viable in any cases. So as a replacement to be viable, NER should be greater than 1. So that's in that case, any that new policy will not be viable. Question number 9. Coal-fired power plant has a life cycle of 30 years. It generates an average of 3,000 gigawatt hour of useful and electricity per year. The EROI, that is the energy return on investment of the electricity generated from the coal power plant, is around 15. Now, how much total input energy does the power plant consume annually? So we have to calculate we have given the ROI. So EROI, we know it's the ratio of net energy output to the input energy consumed by the power plant. Now net energy output we already know. It's given 3,000 gigawatt hour. Here we can see. And we have to generate it. The coal power plant is ROI is 15. So we can calculate the input energy from that. That comes out to be 200 gigawatt hour. And finally, it's 720 terajoules. So these are all the questions of the quiz 10. If you're facing any of the problems, you can ask. Otherwise, we'll move to this week's content. So I assume that everything is clear. So before moving to the numericals, I just wanted the theory short questions. Just wanted the theory parts of that thing should be clear. So this week's content majorly talks about the energy policies. So energy policies are the terms. So we have till now we have learned about energy economics, uh, and environment, and various other factors related to that. So based on that studies that we have done till now, we can make up policies that will be efficient for the human and the environment as well as the economical point of view. So this policies is it's a combination of all these factors considering in one aspect. So what is policy? A policy is a principle or a protocol to guide decisions and achieve rational outcomes. So we have a framework and the policy framework that includes decisions, stakeholders, policies, goals, criteria, and analysis. Now there are energy goals like increase energy access to all, develop capacities for energy transitions, enhance energy security, manage energy related market power, manage energy sources, endowments, reduce environmental and human impact, and accelerate energy related technology change, and coordinate and implement the international energy related policies. These are the energy goals. So deciding energy policies, we have to define we have few scopes and the elements. So scopes can be from a village level to a from a starting IIT campus. Consider the IIT campus as a scope. So it's a very small area. It's having considering 5,000 to 10,000 people, and then area like district containing that, and then finally a village block or Mumbai region, or we can consider the Maharashtra block in India, and then finally the global level. So from the individual point of view or to the global point of view, the scope can vary for deciding a policy. So there can be elements like decide goals. We have to list our policy instruments, where challenges, institution, time horizons, and analytical frameworks. So frameworks from the policies, consider real life examples from that you are familiar with. Describe a framework from the policy formation that can be that's will be done in the theory parts. So I'll just go through this briefly. Classification of the policy instrument. So policy instruments are classified in the majorly in the four thing. First is the regulating instruments, uh, rationing or the performance standards, or we can say benchmarks. Second is the implied deregulation that will be applied from the emission permit trading, green certificates, or voluntary agreements. Then fiscal and financial instrument like taxes, subsidies to the new policies, and fourth one is the supportive action that can be help us into the implementation phase. That is an improvement of the knowledge dissemination and the reduce the transaction cost. So there are impacts of the policy instruments. So in policy instruments, we can see consider the like taxes, subsidies, research, development, and design, and the regulation. These are interrelated with the measures that we are taking, like fuel subsidies, effective investment, product or structure change, and the clean technologies. So these are finally gives at the final outcomes that we are getting the to reduce the CO2 emissions or CH4 or what are the emissions effect that we are considering. So there are few Indian policy document that is available in the open domain. You can always read, like 5-year plans, integrated energy policy, national action plan on the climate change, electricity Regulation Commission Act, Electricity Act, UMPP, and Rural Electrification Policy. These are the old ones, and then you can there are a few more available in the open domain. You can search for that. There are policy options. Options are market or the government, and the uh, regulations. So these are the theory parts. I will not go through this in the detail. Criteria for the analysis policy. So yeah, the major important things in the to how to analyze a policy. So policy and analysis can be done from the effectiveness, its economic efficiency, administrative feasibility, how much administration is required for that, and is it feasible or not. Equity, political and social acceptability, policy robustness, and the policy consistency. So these are the criteria to analyze a policy. Now, there are typical energy decisions that is on the world level, that is an international agreement, national level, that's a energy policy pricing. At the state level, we can say that the taxes, incentives. At the district level, we can see the fund allocation to the blocks. At the block level, we can see the funds allocation to the gram panchayats, kerosene allocations. And the gram panchayats level, we can see the typical energy decisions, that is agriculture or the cooperative industries. And the household level, we can have a energy decisions that we can choose our fuels and the devices that we are going to use. There are other energy policies like building codes, standards, and labeling, carbon taxes, energy, renewable energy certificates, and certificates, and the trading, and the carbon taxes. This thing we have covered in the lecture number 2. So this is the supply and demand curves, and we can vary according to this. So if we will see here, this is the original graph. Just wait a minute. So this was the original graph. If we will change the production subsidy from this, then we can see this graph will change to this one, and the overall things will be going to change. So there are a few examples study to study this topic. One is the policy framework. Sorry. Yes. So there are few policy frameworks that examples has been taken. Like an institution is taken as the Delhi government. Uh, Police and CPCB analysis has been done for the number of vehicles. So that is a example of a policy framework that is done by the government of Delhi government, and the odd even analysis in before the COVID time. So they are allowing the only the some kind of odd vehicles to the odd dates and even vehicles to the even dates. So based on that, they are analyzing the. So there has been a study that develops what is the pollution level in between the this region when the odd even policies are implemented, and the pollution level before and after implementation. So there, the goal was to improve the air quality of Delhi during the winters, and the stakeholders are urban residents, taxis, public transport officers, and the policy framework that has been done. So this has been done in the two phases. One is from the January 1 to 15. Second is the 15 to 13th of April. And then there are two regions that has been studied. One is the Delhi, and second is the Faridabad. That's a nearby area of the Delhi. So two examples has been considered. One is with the implementation. The second one is the implementation of the odd even. And majorly we can see there's a gap that is a on the different hours of the day. We can clearly see there's a pollution PM 2.5 reduction from the Delhi to Hyderabad with the implementation of that because reduced traffics. So that has been a good example of that. What is the implementation of the policies? This study has been done by EPIC. If you want more details, you can go through this. That's available in the references. Now, some more studies are being done in the same manner. So this has been explained. Now, another example is the INDC. INDC is the goal to limit a global temperature rise to less than 2 degrees Celsius to compel the global consensus and limit CO2 emissions to provide voluntary response from the India. The instruments are there has been a MOEF, that's the Ministry of Environment and Forest, MNRE, the Ministry of Renewable Energy, IPCC in the impact assessment and climate change. Stakeholders are the government, people, fossil fuel and energy industries. So these are the stakeholders. So this is the INDC, the India's stand in the IPCC, and they have started with they will reduce the carbon intensity of GDP by 33 to 35% of the 2005 level to up to 2030, and to create 40% of the cumulative non-fossil fuel power installed capacity by 2030 using finance from the Green Climate Fund. These are the three commitment that has been made by India, and to create an additional carbon sink of 2.5 to 3 billion tons of CO2, sorry, equivalent to additional trees cover in the forest. Now, what does the carbon intensity of the economy depends upon? So carbon intensity studies there has been matrices that has been studies the carbon intensity of 2030 versus 2005, energy intensity of 2030 versus 2005, and the equity impact on the jobs, cost of transition, carbon sinks, etc. There have been several policies that are mentioned here. You can go through this if you want. And 25 solar parks, ECVC, greenhouse, environment of like building energy codes, how to make a efficient building that will consume less energies and efficient homes. So these are the references. If you want any of these studies want in detail, you can go through these references and then you will get all the details about it. If you have any questions till now, you can ask. So another part is just an examples of energy policies. So there has been examples like cooking or rural electrification. As we can see, the increasing the prosperity and development versus increasing flexibility and convenient to technical crops. So initially, if we see that no money is involved or a very low income, then most of the power that is being consumed with human power. If you have some more income and you can afford some animals, then there will be animal power. And you have low to middle income, then renewable or the natural power you can use. And if you have the middle to high income, mechanical power from the fuse, and finally high income, you can consider the electrical power. So these are the mentioned in the GEA, Global Energy, in the chapter number 19. You can visit that chapter if you want. That this is called a mechanical power ladder. So energy access. So energy access, it's a definition, a household having a reliable, affordable access to both clean cooking facilities and to electricity, which is enough to supply a basic bundle of energy services initially, and then an increasing level of electricity over the time to reach the regional average. So this is the definition of energy access by IEA. Now, why I'm teaching this all these theory parts, because these are the from this is the and expect the questions in the final exams that suppose you could be asked what are the stakeholders, like you can consider what are the energy policies out of these. So you can consider the one of the options will be given is wrong. So you can be, so I will try to solve this type of questions so you will get more clarity. Being back to, so energy access policy like BPL scheme, electricity connections, Bhagya Jyoti scheme, Pradhan Mantri Har Ghar Sahaj Yojana. These are few policies related to health, environment, and impact of traditional fuels. Now there has been studies has been done between the different fuels. There has been like kerosene, LPG versus electricity based. These are called the latest one. They called air fryers. Now access to electricity versus the poverty level. If you will find India is a percent of population with the electricity access. So more than 60% of the population is having the access of electricity, and the percentage of around 70. This is the old data, so that data has been changed. Now it's all be explained by the sir. If you want more about this, you can go the videos again. Oh no, if there's anything left. Yes, one thing is the disability adjusted life years. So daily, yeah, this thing we have covered in the I think lecture number 2 or 3 itself. One daily can be uh, thought of as in a last year of healthy life. The sum of these dailies across the population or the burdens of diseases can be thought of a measurement of the gap between the current health status and the ideal health situation where the entire population lives to an advanced age, free of disease and disability. So one DLI will be one healthy life of the year of the life lost plus one healthy year of the days. So suppose you will be given the one YLL value, you have to and the YLD, you have to calculate the DLY in the numerical. So you can expect this type of questions. Now, so this is all. If you have any questions related to this, you can ask. Otherwise,
Sir, what is INDC, sir?
okay. If you don't have any questions, then I will move to the problem solving session.
Sir, what is INDC mainly meant for, sir?
Can you please repeat?
INDC.
INDC.
Yes.
So INDC is India's nationally determined contribution to the UN. INDC stand for this intended nationally determined contribution. So there has been three things India has contributed. So I will explain just here. So these are the three commitments that has been made by India to reduce its carbon density and to generate more powers from the renewable energies and to increase the carbon sinks available. Is there any other questions? Okay. So let's move to this week's problem solving questions. This week we have a very few questions because it's basically all theory part of this. So we will solve queries available if you have any in the previous weeks, or we will solve the numerical questions related to the few previous week that I've given to the as a homeworks that may help you in the solving the questions like internet related uh, questions already. Sorry. So question number one is Bharat's stage emission standards. It's a policy instrument applicable to vehicles in India. What type of policy instrument it is? First
It is
is
a
regulating implied deregulation, fiscal, financial instrument, or supportive action. If you want to answer, you can unmute yourself or you can write down in the comment box also. I'm seeing both.
it is regulating mechanism.
Regulating mechanism is the correct answer. Let's see the chat box. So since it is a emission standards, so emission codes, performance standards, etc. related to this are regulating instruments. Uh, regulating instruments. Another like question number two. When a production production subsidy or consumption subsidy is provided on a fuel, the environmental damage increases or decreases? That's a good question. Anybody want to answer?
This increases, sir.
How so?
So when we get the subsidy, we have to using in the fuel more.
Yes. So it's correct. When you get the subsidy, you will consume more and more fuel. So that's why it's increases. So increases is the correct answer. When uh, subsidies when subsidy increases the fuel use and subsequently it increases the emissions and then it increases the environmental damage. So I hope these two questions are clear. Now moving to the question number 3, it says LPG subsidy is a instrument to encourage use of LPG among those who can't afford it otherwise.
So it is a physical and financial instrument.
Correct. Correct. Because it's not a regulating instrument, neither it's a supporting action. So LPG subsidy is given in the terms of
Money.
financial assistance. Correct. So any kind of subsidies, the the taxes and grants, it comes under fiscal and financial instruments. Question number 4 says the resistance of a policy to external factors such as any change in the environmental or political conditions is reflected by which criteria? Someone is typing policy robustness. So yes, policy robustness is the correct answer. A resistance of a policy to external factors such as any change in the environmental or political conditions is reflected by policy robustness. It shows robustness is the robustness itself means robust. How can it withstand adverse conditions? So any adverse conditions like political or the environmental changes, it can be reflected by the policy robustness. So robustness means it means policy remains the same despite of external factors. I hope it is clear. Now, question number 5. So this is the analysis that we have just recently studied.
Sir,
Consider an analysis of odd even. Yes.
what is the physical example of implied deregulation. Why are we using implied deregulations? What is the common example in policy making?
Implied deregulation. Can you please where it is means it's not related to the previous question.
No, sir, I am just asking, sir. There is a one item is that implied deregulation. What is meant for that implied deregulation? Uh, what is a
I think
practical
you're talking
example of
about
implied deregulation?
implied deregulation. Even I have to go through. I'm not sure what is it. Because it's so it's a big concept. I think I can't cover it unless I am sure about it. So I'm not sure about what it means. So maybe in the next
Okay.
class I will note it down and I will explain. I have a few slides on that, so you it will be clear to you. Okay.
Yes, sir. Yes, sir. Thank you.
Okay. Now moving to the question number 5. Consider this is a question is based on the analysis that we have studied. That is the odd even policy launched by government of Delhi. So we have two columns. One is having policy instruments, and second is the stakeholders. Uh, so we have to match the uh, column. So column one, first thing is the institution, policy instruments, goals, stakeholders, method of analysis. So as we can see, what should be the institution of this can be matched from the column number 2. The institution can be do the command and control. A policy instrument is instrument is sorry this is mismatch. So institution, as we have studied, if you will go through this, institution is Delhi government, CPC and police. If you remember, uh, just I'll just revise it so that you can answer. And yes, so institutions is Delhi government, CPC and police in this case, and other things are like stakeholders are these ones. Goals is to improve the quality of air. Mandate is to command and control analysis. So if you've read this, then now you can answer these questions. So institutions, we are clear. Institution is the Delhi government. Second thing is policy instrument. What is policy instrument?
Command and control.
First, policy instrument is command
Command
and
and
control. Correct. So first one is E, second one is D. So basically it is D, it is E, it's wrongly written. And the goal, what is the goal? Goal of audubon policy to improve the air quality.
improve the air
So
quality of
it
the
goal
city.
will correct. So third one will be B. Fourth one says stakeholder. Who are the stakeholders?
Residents, public transport
Residents.
and police.
Correct. Stakeholders are these people. So fourth one will be A, and finally left with the fifth one. Method of analysis is to change the PM 2.5 level. So fifth one will be C. So correct option will be in that case E is option number B. So this type of few more questions you can expect in the your exams based on the things that has been taught in the theory part of this lectures. I hope it is clear. Now moving to the question number 6. ECBC and Terry Graham. So ECBC, Terry is a one institute that is located in Mumbai. That is a and do the studies related to the energy. ECBC stands for Energy Conservation Building Code. That stands for the ECBC. Same, yeah, Terry Graham. So these are both the policy related things. Basically, the building energy codes. So comes under what category of energy policies? Standards and labeling, preferential tariffs, no. Building codes, yes, it comes under the building codes. So these two both are the uh, building codes for the more efficient and energy efficient buildings that will consume less power. Just wait. Anything else related to this? Okay. Now ECBC, these are the launched by the government of India. Government of India to promote what is the reason to launch its launch to promote energy efficiency, green rating, and decrease to utilize natural resources such as light in buildings. So GREHA stands for the green rating for integrated habitat assessment. It's both are developed by the Terry as a rating system for the building and building green buildings. So I hope it is clear. Now, question number 7. Which among the following are the stakeholders of India's intended nationally determined contribution, that is INDCs, to the UNFCC? Government of India, uh, financing institutions, energy industry, or all of the above. So it's asking as the stakeholders of these INDCs to the UNFCs. So according to you, which of who are the stakeholders?
So all of them are
Correct. So as we can see, Government of India, financing instrument, and the energy industry. All of the above should be the correct answer. See the chat box if you have any doubt till now. So I hope everything is clear till now. Now moving to the question number 8. It's the last, not last. Yes. India's INDCs commit to reducing the carbon intensity GDP by 33 to 35% of the 2005 levels by 2030. This can be achieved by reducing the carbon intensity of energy sector, reducing the energy intensity of GDP, change the structure of economy, only A and B, or all of the above. It's a tricky question. You have to go through it briefly. If you want to answer, yes, if someone is commenting all of the above. So, India's INDC commit to reduce the carbon intensity of GDP. First thing is the reducing the carbon intensity of the energy sector. It's related, correct? Reducing the energy intensity of GDP. So it's also true. Second one, like third one, change the energy structure. So these all these things, energy structure means from what we are generating the electricity. Currently, we are generating most of the electricity from the fossil fuels. So if you will change that structure to go for the renewables, that will help us to reduce the carbon intensity of GDP from 33 to 35%. So the correct option will be all of the above. So if you want more details, it's like carbon intensity of the energy sector refers to the carbon emissions per unit of energy generated. Carbon intensity.
Sir, good evening.
Good evening.
Sir, option C it states that change the structure of economy. Is it same
Yes.
to change the structure of energy sector? Change the
It's asking the
structure of economy
like,
means
yes, yes, please go ahead.
no. I am confused that as you said that change the structure of energy sector. If it is mentioned in as energy sector, obviously that could be the answer. But it said that structure of economy. Economy means as a holistic way. It is says the Indian economic structure or only for energy related economic structure.
Okay, thanks. It's a good question. I'll just go through this. Just give me 2 minutes. I will just complete this and I will answer your question. Okay.
Okay, sir.
Okay. So for what we are doing, carbon intensity. Carbon intensity is refers to the emissions per unit of energy generated. So this refers to the carbon intensity. Sorry. So this remains about the what is carbon intensity. It means the emissions per unit of energy generated. Now energy intensity of GDP. Energy intensity of GDP refers to the energy consumed for every GDP. Now reducing the carbon intensity and energy intensity reduces the emissions, therefore the carbon intensity of the GDP. Now shift the economy from energy intensive from less energy intensive. So here is your answer. If we shift our economy, shift our structure of economy from energy intensive industrial sector. What are those? Steel, iron, or power plants or manufacturing sector, to less energy intensive sector like IT or service sector. So this will help us to reduce the overall carbon intensity also. I hope
But
you have
sir,
understood.
this transition is looking like vague, na? We can't just escape our steel industry, the
No,
manufacturing
we can't
industry.
escape.
We can't only
Correct.
economy can't rely upon only the tertiary sector of, as you mentioned, IT. So
Correct. So we are not shifting it. Suppose whatever the instrument, suppose there will be some why we are generating the steel or why we are generating the cement, because we need more and more construction or requirement of that. Once the development, why these industries are going for the decline in the in the developed countries, because all of the developments has been done in that countries, and all of the things are required to only for the maintain that. When our country will be developed, all these industry will be not that energy intensive, as well as requirement of these things will not be that much. So at that time we can say that changing from changing that like if you see an example of energy intensive, suppose mm, there are few things that are not making any sense right now. So if you see considering a cycle manufacturing company, so that was also a company that makes, but currently as you can see, like there's a company in the Gurgaon that has stopped manufacturing cycles, that is Atlas, I think. So due to that, at some time it was making more sense, and it was one of the highest crossing company at that time. But when the requirement of these things decreases, then change of structure of economy should also changes. So currently, you're right. It's making sense that we require these industries also, but choosing more energy efficient solutions and for the future energy scenarios. If you want to achieve carbon neutrality, then changing the structure of economy will be one of the major factors on that.
okay, sir.
Is there anything
Thank you.
else? Okay.
No, sir. Thanks.
Now moving to the question number 9. Mhm. Dash is the policy, refers to the area, region where the policy will be applicable. Yes, someone is commenting. There are four options: scope of a policy, stakeholder, goal, or clause. It's a basic question you can all of you can answer. Just thinking if there's anything else I can. So here the right option will be the scope. So what scope is? Scope of a policy refers to whom or in which area a policy will be applicable. It can be an institute, it can be a city, it can be a country or a village or a global level. So that's why scope is a policy refers to area region where the policy will be applicable. I hope it is clear. Now moving to the question number 10. Which of the following is not a regulating instrument? So we solved this type of question initially. I think you must be able to answer that.
So tax.
Correct. Taxes are the correct option. Can you explain why?
So it is imposing it is physical or financial. Yes, just like LPA subsidy, where we are giving some monetary benefits in terms of some subsidies or in tax. But for um, other other thing, the regulator is just like emission control, that Bharat stage 1, Bharat stage 4. These are all are example of regulating, where we can regulate or imposing some technologies or adding some carbon catalyst in the machines or equipments or in IC engines along with that, and we are getting that targeted value, the reduction of carbon emissions or that the SOx NOx emissions from the vehicle. So it is
Correct.
just like
Very
I'm
good.
thinking.
As we have also studied this thing in the this example, subsidies, taxes or grants, these all things comes under the fiscals and financial instruments. So these we'll see here. Yeah, emission codes, as you explained, are the regulating instrument, performance standards, enforcing mandatory. No, it's not a regulating instrument. So taxes are taxes, subsidies, or grants comes under the financial or fiscal instrument. So right option will be taxes. Now moving to the question number 11. A star rating system which depicts the energy efficiency of an electrical appliances comes under which type of policy? Standards and labeling, preferential tariffs, building codes, or carbon tax? It's a very easy questions
It
you
is
can
stand.
answer from the
It is standard everything.
standards and labeling. Correct. As we have seen,
Normally,
this is made
in a sir, Bureau of Energy Efficiency.
correct. So that's uh, star rating system is developed by the BW, Bureau of Energy Efficiency, BW. Okay. Now moving to the question number 12. That's energy efficiency. Now question number 12. Dash is the policy is the ability to achieve the goal that was set in the policy. What is that fact? Consistency, robustness. It will not be that thing. Effectiveness, correct. Effectiveness is the right answer. So I'm seeing the comment section. Effectiveness is the right answer. So I think we are done with this short type of questions. If you're facing any doubts, you can ask. Otherwise, we'll move ahead with the short type of questions. Okay. Let's see the first question. There's a steel industry has been annual production of 15,000 tons. The cumulative energy demand, that is CED, is 2 megajoules per kg. Now find the total energy consumed over the entire lifetime of the industry, that is 40 years. Find the carbon emissions footprint, CEF, of steel in kgs per CO2 per kg of steel. If the total CO2 emissions of the plant over its lifetime is 1000 kilotons. There has been few data that has been given. First thing, we should know about what is CED. So CED is, it is the ratio of total energy input to the process for lifetime. That's basically a lifetime energy consumption divided by the life years multiplied by annual production. So we know the total energy for the lifetime, the option number one, first thing we have given 2 megajoules per kg. So CD of this thing is given. This thing is given 2. What thing we have to find the total consumed over the entire lifetime of the 40 years. So we have also given, we have few data that has been given. We have given the lifetime, that is 40 years. Annual production is given 15,000 tons. So tons we can multiply by 10 raised to power 3 because this thing is given in the megajoule per kg. That is megajoule. Different fonts. This is given in the megajoule per kg. Now it's also under kg. This is years. Now we need to calculate the what is the total input energy. Write it. So if you'll see total energy output or T, total that would be equal to 2. The thing will go there 2 into 40 into 15,000 into 10 raised to power 3. That comes out to be 120 into 10 raised to power 7 into 10 raised to power 6. So why we're doing it 10 raised to power 6? We're converting that megajoule to joule. And finally, the whole things will be converted into terajoules. Then it will be around 1,200 terajoules input. So we calculated the first part. Find the total. I hope it is clear. If you want any explanation, it's just a basic unit conversions that we have done. The second part they're asking, find the carbon emissions footprint for the steel, that is kg. We have to find that is CEF, kg of CO2 per kg of steel. So that means they're asking how much of CO2 emissions is generated to generate a kg of steel. So CEF, we have formula is total CO2 emissions of the plant in its life divided by life multiplied by annual production. So CEF, we can total CO2 emissions we have given, that is given here 1000 kilotons. 1000 kilotons. So first of all, we will convert the kilo to 10 raised to power 3, then one more 10 raised to power 3 to kgs. I think someone is unmuted. Can you please mute? Okay, thanks. This thing we finally converted into the kgs. Now life is given 40 years. 40 years and our production is 15,000 tons to convert the unit of this to kg per year. This is in the year. So these two things will be cancelled out. Kgs to kg. So we know if we will multiply all these things, you will get around 1.67 kg of CO2 is emitted per kg of steel. Is it clear or you're facing any difficulty to grasp it? So now we have calculated the both the things, CF and input energy. So similar type of question, if you are not facing any problem, I will go ahead.
Sir, kindly go back to the previous slide. Just
Yes, yes.
yes. Six, 14. Okay, sir. Thank you.
Okay. Is there anything else?
Sir, previous
Okay,
slide
then if
question.
this one.
Okay, sir. Okay.
Okay. Okay, if there's nothing else, I will give you a question to solve. So this is similar type of question as for the zinc production facility having an average annual production of 118 tons. Cumulative energy demand is given. In there also we have to find the total energy input and for the lifetime 30 years. and the total CO2 emissions of the entire lifetime is given. We have to find out the carbon emission footprint. So I'll give you 2 minutes or like 5 minutes to solve this question. It's similar in this in the from the previous question. If you're not unable to solve, I'll just solve it. Yes, and even if you're able to solve this question.
17.7 terajoule.
17.7 terajoule. Just a minute. 17.7 terajoule. Yes, it's a correct answer. So total 17.7 tera. Second thing,
Second thing is 0.8.
0.8. Correct. Very good. So both the options are that you have always correct.
Sir, one question
Is
is
there
there.
anyone? Yes, you
Sir,
can ask.
is there the in assignment, is there any that proper question, I mean, proper answer is not given for 4 options, then what will be done?
And you should choose the nearest answer. What should
Choose the
be the
nearest answer.
most
Suitable.
go for the nearest answer.
Okay.
Okay, so I will just briefly explain. So CD formula we know. CD, I will not explain it. I will just take it from there. CD is total energy input of the lifetime to the divided by lifetime into the annual production of the product. So CD we have given as 5. So 5 we can equate with the total energy input divided by lifetime, that is 30 years, divided by multiplied by total annual product, that is 118 tons into 10 raised to power 3 to convert this tons to kgs. Now, if you multiply all these things for it into 30, it comes out to be 17.7 to 10 raised to power 6 megajoules. That will be equal to 17.7 terajoules. So first thing we get it from here. Second thing is they're asking CEF. So CEF, we've just taken, it's a total CO2 emissions of the plant in its life divided by life into the annual production. So here it is given 28 2 tons. So tons we will convert into the kgs by multiplying by 10 to the power 3 kgs, and lifetime is given 30 years multiplied by total production, that is 118 into 10 raised to the power 3 kgs per year. So this thing will be cancelled out. CF will be 0.8 kg of CO2 divided by per kg of zinc production. So now both now from the question number one and the question number two, which one is the most now I have a question. This thing we have solved for the steel industry. This thing we have solved for the zinc production. Which one of these industry is having more carbon intensity?
Still,
Steel. Correct. Because we have physically seen it's around 2 times more carbon intensive than the zinc production. That means steel is a process that takes more power to generate a per kg of steel rather than the zinc. Although zinc is costlier than the steel. Okay. Now, if you have any questions from the today's problem solving session, otherwise I'll solve few questions related to the previous years, previous lectures. Or if you have any other doubts from this session, you can ask. Okay. Hope you don't have any. Then I will continue with this tutorial questions. Or I will start with this type of question. We have few more questions. So input output table. These are the questions that are given for the homeworks. You are facing any problems? One more question I have.
sir, it
Fuel
is
cell
it's
success.
to the UTF inverse, sir.
Yes, yes, you can ask.
Sir,
Which one?
sir, the last one is related to the Leontief inverse.
Correct. These both of the questions are related to the Leontief inverse. Question number. I think I should start with this one. This is more related to this week's question. Compare a fuel cell based system. Okay, let's solve this one. Suppose an economy consists of two industries. One is steel, second is automobiles. In order to produce automobiles, the economy requires steel and automobiles. Similarly, in order to produce steel, economy requires automobiles and steel. To produce 1 rupee worth of steel, a steel industry requires 2 paisas worth of steel and 7 paisas worth of automobiles. And to produce 1 rupee worth of automobile, an automobile industry requires zero point 0.5 paisa worth of steel and 1.1 paisa worth of automobile. Now also suppose that economy has an export of 15,000 worth of steel and 5,000 worth of automobiles. Now express the above problem as an input-output problem. How much of the worth of steel and automobiles should be produced to meet the total demand? So first thing, we have to make a input-output table. Let X to be the steel production, Y to be the X to be the total steel production and Y to be the total automobile production. Now we will make a input output table that will include steel and having a steel, we will having a automobile and exports. Exports will be in thousands. So we have steel, we have automobile. As we've given, point 2 paisa worth of steel is required and 0.7 worth rupees of automobile is required to 1 rupee worth of steel. So that will be requirement of 0.2. Steel to steel will be 2. Steel to automobile will be 0.7. Similar things will be given from 0.5 to zero point 0.1, and that will be 0.5 and zero point 0.1. Export is 15,000 and 5,000. So we have already taken 15,000 because it in thousand. So it is 5. This is we have developed a input output table.
Sir, can you go back to the previous slide, please? I missed it.
Yes,
Previous.
this one.
Yes. I just need to. Okay, sir. I just need to some data.
Okay. Now mathematically, we may express this total production of steel as we have considered the X and Y. So X would be equal to 0.2 X itself and as you have seen and 0.7 and 0.5 Y plus 15. This is we can call it equation number 1. Similar manner we can write Y 0.7 X plus 0.1 Y plus 5. This is equation number 2. Now equation 1 says total steel is produced by using steel automobiles and a part of production goes for the exports. Similarly, equation 2 says a total automobile produced is by using steel and automobiles, and the part goes to the exports. The export may be considered as a final vector. Export is the final vector. Now, so we have already done the first part of question. Express the above problem in the input output model. So this we have maintained a table. We have developed a input output table and derived into the mathematical part. So this is how we have solved it into the problem as an input output model. This is input output model. A second thing that they are asking, see it. They're asking the how much of the worth of steel and automobile should be produced to meet the total demand.
सर
So now
लास्ट स्लाइड
using
मिस हो गया थोड़ा.
yes,
ओके ठीक है. हाँ.
using matrix algebra from equation 1 and equation 2 may be expressed as x y is equal to 0.2, 0.5, 0.7 plus this is we have written in the matrix form. Or similar thing we can make it as a z plus e. This is the same format. So z we know that's I minus a e. That's a Leontief matrix. When we calculate these things here,
Sir,
z
please
is
go
a
to the
2
last
into
slide. Sir, please go to the last slide.
yes.
AZ. Sir, what is AZ, sir?
If you are
It will
considering
be
this as a z, if you're considering this as a, then what it would be? Is it
it is Z.
that would be
Okay,
e. Right.
it is E plus E. So Z is equal to 1 minus A T E.
And when you solve this, simplify that equation, it comes out to be z is equal to I minus
The
a
previous
inverse
equation
to
you have.
e.
Okay, got it. So, then it is it.
So that thing I'm explaining in the detail now. Z we know z is a 2 cross 1 column vector, and A is a 2 cross 2 matrix of coefficients, or we can call it a technology matrix. Similarly, E here is a 2 into 1 column vector. Here we have taken as E as a E because E means exports. Now from the equation 3 that we have developed here, equation 3 may be solved using matrix inversion. So I minus A inverse is, we know I minus A inverse is adjoint of I minus A divided by I minus A mod. This thing we know, correct? I minus A equals to 1 minus 0.2. I'm solving this thing in detail because I'm not solved it yet. Just wanted to, if you have any doubt, you can just take this as a reference and solve the previous problems also. Also to be 0.8 minus 0.5 minus 0.7 or this is I minus A. If you calculate adjoint of I minus A, it will be 0.9, 0.5, 0.7, 0.8. That's very basic. You can just take this as a replacement. Like if you want this one, you have to take this comes out to be this, like this. You have to solve. Now for further solving, I minus A equal to 0.8 minus 0.5, 0.7 minus 0.9. When we solve it, it will be 0.37. Now Z is equal to I minus A inverse into E. So adjoint we have calculated 0.37. Let's simplify it. Adjoint I minus A, I minus A to the power E.
Sir, please,
E would,
please go previous slide, sir.
yes.
Yes. Okay, sir.
Okay. Now we have to just put the values. Adjoint I minus A we have calculated here. Mod we have calculated here. We have to just put the values. Adjoint so mod we are taking as a 0.37. We know 0.9, 0.5, 0.7 and 0.8 multiplied by E. So E we know 15 and 5. Is that? So when we multiply these things, finally we will get a column vector of 43.235 and 39.189. Or we can say xy is equal to we have calculated the values of x and y. So now we can say since the values are in the 1,000 rupees, so the amount of steel to be produced is worth 43,235 and amount of automobile that needs to be produced is worth 39,189 rupees. I hope it is clear. If you're having any doubt, you can ask.
So, sir, but the diagonal must be more than normally in class, sir, describe that the diagonal should be more than one for uh, in
So here we have to consider we are not taking the absolute values. We have already considered 15 and 5 as in thousands. That 0.9 is 0.8 is coming because you are considering it as a paisa. If you change the units, then your diagonal will be, I think, 37.
sir, is there any criteria to fulfill the Leontief that all the coefficients in the diagonals are the greater than one? Is there any criteria fixed for Leontief inverse? Because there is 0.9.
Yes, I'm not able to understand your question. Please can you repeat?
Sir, here that the final is the 0.9 and 0.8. That last in Leontief, sir, it's just
Yes.
here.
Yes.
0.9 and 0.8.
Yes.
But in class,
Yes.
sir, saying that diagonal, this diagonal should these two coefficient, this diagonal two coefficient must be greater than one. Is there any
Yes,
criteria
these
for
are
that?
greater than 1. It's still greater than 1. You're forgetting the point 37 outside the matrix. If you put that inside, that 0.9 divided by 0.37, it will be 2.43, and
Okay.
0.8 divided
Yes,
by
yes,
0.37, it would be 2.16.
yes. Okay, sir.
Correct?
No, yes, I'm getting.
Okay. Okay. So anything else? Any one of you? So we have covered 11 weeks of content. If you're having any queries related to the exams also, there will be one more session that will be in the next week. You can ask your queries, if any, about all the sessions that have been conducted till now.
Sir, may I know that when we will get the hall ticket or everything? It's almost 10. Is there
I think hall tickets you can generate from the uh, portal itself.
portal?
Yeah, there's a
Which portal, sir?
portal. If you will just, yeah, just that means.
But normally that NPTEL send this message that you have to download or something else. They have to
Yes,
provide,
yes.
na sir, because they are giving a message in your email or in some way that you have to collect your from download from that your uh,
It
admit.
definitely they will send. I'm just checking it. Is it available or not?
And also there is not such announcement in the NAPTEL portal. Every weekend feedback or new week's lesson, whenever it
Yes.
comes, all the information it is also shown in the announcement, but it's not still not showing in the announcement section. That's why I
Because
So
asked.
if you're going for
uh,
the general, I think if you see this
because
tab,
your previous classes we have to see from YouTube itself, not from NPTL,
no, no,
because
no, no,
your
you
institution
can
have
see directly from the NPTEL itself. Let me just show you to how. I will just send a link separated by all the channels available in the like all the links considering in one file. I will text it to tomorrow itself. So I will just send it week wise content and week wise lecture videos and all the contents in the one file. So I make sure that the other TAs will be send this in detail to you. So if you will see NPTEL here, like this is the course. If you will sign in from here, so I'm just signing in from my Google account here. So here, if you will see, this is the content. If you go this tab here, download videos, okay, just below this problem solving session, then you will there's one more tab open. If you click this, then you will find this problem solving session recording here. Click here. If you click here, then it will directly redirect to you on this Excel sheet in which the week wise content is given from the YouTube link and the presentation folder. If you will convert this presentation folder, then you will get all the details like week 10 if I open whatever the slides I'm using, you can access these slides also. You don't need to make notes. You can just try focusing. All the annotations and all things are there already. I will send a message to your team that will send you all the details and the one mail. Tomorrow you will get a mail. Okay.
Actually, sir, I have sent a mail also in the Q&A that whenever we'll get the hall tickets and everything, but no
So
response.
I think hall ticket, if you will find here, if you will type your NPTEL hall ticket, then it will the first link that is coming here, NPTEL. Then you have to click January to April NPTEL exams. If you will click here, then sorry, my mail ID is not registered. Can you check here right now? So maybe your hall ticket is out.
So let me
Please,
check then. What
yeah,
should I
yeah. Please,
type?
you should type
Nap
NPTEL hall ticket.
hall ticket. Same it is shown to me also, sir. Your email ID does not exist. Why is it?
Okay.
After click here, I mean after showing the Jan to April, your email ID does not exist. Why it is so?
Okay, I'll ask the team to means confirm it and write like answer your query on the NPTEL Q&A itself. Okay, so that will be
Okay,
done,
sir.
but tomorrow afternoon. Is there anything else that I can help you?
No, sir. Thank you.
Okay, thank you. So I'll consider this class is done, and if you don't have any doubt,
thank you, sir.
okay, thank you. Good night.